Happy Wednesday, my friends. So this video is going to be a tutorial on ChromaDB. And ChromaDB is basically, according to their words, an open source AI application database with batteries included. Basically, it's a database for embeddings, vector search, document storage, full text search, metadata filtering, and it has multimodal, so it can handle images and text. So in other words, it's basically a database to help you with your RAG or retrieval augmented generation applications, as opposed to just storing it like on desktop or whatever. So it's basically like a database for these RAG applications, right? So you can go to this trychroma.com and you'll get this thing. It has a get started thing. And my tutorial, a lot of it's going to be based off that. So let's get started. By the way, you can run it as a client-server mode. It has async functionality, and it's constantly in development. So eventually, this will be much more mature than it is today. And eventually, they'll have a hosted version. And very importantly, it's compatible with all the LLM development frameworks like LangChain and Llama Index. So why on earth do we care? Why do we want to use like a ChromaDB or like a vector database? So basically, if we just store embeddings in like in memory or in a file, that sort of thing, we won't necessarily efficiently be able to like search things. So ChromaDB gives you like a very efficient vector store and retrieval, and it's very flexible. Like you can basically, like, once you have a database, you can call it from another application. You don't need to like always move this stuff in memory and stuff like that. Okay, so let's get started. So this video is going to really be in two parts. The first part is I'm going to give you like a brief overview of ChromaDB, show you how to query based on like semantic similarity, like, and also show you how to further filter based on text and metadata. So you can basically search for documents most similar to your query, but you can also add conditions that the text contains certain things, or the metadata fields contain or equal certain things. So I'm going to show you like a brief overview of that, and then I'll show you how to further customize this by persisting it to disk, maybe basically saving your database for using it later on, so you don't have to like redo your embeddings and that sort of thing. Also, like, I'll show you how to customize the two important components of a RAG application, basically the embedding function for the text embeddings and the distance function for vector search. Okay, so let's get started. So the first thing we need to install ChromaDB. And I also installed something called sentence transformers. The sentence transformers is just because that will help us with like the custom embedding function later on, using the sentence transformer library. But ChromaDB is really what you need. Okay, so our application will be on showing you how to do this querying with earnings transcript data. So I have this file in my GitHub, and I'll give you a link to this Google Colab and this CSV file. Of course, if you guys like my videos, please like, please subscribe, please share, please comment. It does help a lot. Thank you guys so much. So the file looks like this. You have a symbol like Tesla. You have a quarter, year, and the date in which the earnings happened, like when it started and that sort of thing. So, and you also have the content, which is basically the transcript. So just to show you, the content looks like this. Oops, sorry, guys. Okay, so the content looks like this. It looks like df.iloc0.content. Sorry about that. So like the content looks like this. Oops, I guess I didn't click this. So if I print the content, you'll see that the content is the full earnings transcript. Like Elon is talking, then Ashok, that's the AI magical person, and Lars and that sort of thing. So you have the content. This is the earnings transcript. So it's the entire earnings transcript, right? So this is what we want to embed in our database to search over. To be honest, this is a very long earnings call, so you really would want to probably split this up into chunks, and there are tools like Llama Index that help you do that very well, as opposed to just having an embedding of the entire document, because it's very big and there's many topics it discusses. But for simplicity here, we're just going to embed the entire document, which is the entire earnings transcript. So let me show you guys how to do that. So the first step is you want to create a Chroma client. So you do import ChromaDB. And by the way, this is my second recording because I accidentally didn't have enough storage to record to keep the first one. So I'm a little bit tired, but hopefully this will be okay. So you do Chroma client equals ChromaDB.client. That gives you the client. Okay. And now you want to create a collection. So think about a collection kind of as like, if you're familiar with SQL databases, it's kind of like a schema. And in a specific collection, you'll store your embeddings, documents, and the metadata. So you can have like maybe one collection could be like your earnings transcripts. The other one could be like news data. The other one could be like, I don't know, if Elon lowers the Twitter API cost, it could be Twitter tweets, that sort of thing. So you can have many collections. So we'll show you here how to create one. So you can do collection equals Chroma client.create collection, and we can call it name equals earning transcripts, but maybe we'll just call it my collection. So this is your collection, right? And okay, so now that you have your collection, we want to add our text documents to the collection. So how do we do that? So first of all, we need a list of text. So that's going to be the documents field. So like I said before, you really would want in the earnings transcript to actually split these long earnings call into chunks. But for now, we're just going to make it as a entire, we're going to like consider like each entire earnings transcript as just one text. So we have the list of these earnings transcripts, which is our documents. Metadata is going to be a list of dicts with metadata values. And IDs is like the unique identifier. Think about it kind of like as a primary key to uniquely identify the records. Okay, so let me show you how to do this. First, let's get the documents from the data frame I showed you above. So documents equals df content dot to list. That's the documents. And let me show you guys kind of how it looks like. I'll show you the first document. So this is the documents. Okay, and now we want the metadatas. So let's do it into two parts. So we'll have the columns we want. So metadata calls. And we want basically everything except the content. So we can do like symbol. So remember from the above data frame, we had basically we had symbol, quarter, year, date, and content. So here we want symbol, quarter, year, and maybe we'll have a date. So these are our metadata calls. So to get metadatas, we'll do something like this. We'll do the data frame with these columns, and we'll do to dict orient records. Then that gives you in the right format, which is a list of dictionaries. As you see, like I did, here I take the first two. And you see I get a list of dictionaries with like the metadata columns like symbol, quarter, year, and date. Okay, so that's the metadata calls, and now we need the IDs. So for simplicity, I'm just gonna basically use the data frames index and just call it like ID underscore data frames index. So I'll do like f string this for I in. You know what? Let's do it like this. Actually, I'll do df.index dot to list dot so index is a type. Yeah. So sorry. df.index dot to list. So this will be the index, and then I'm gonna do like this. The autocomplete sometimes screws you up, so I'm gonna do the F string. I'm gonna have ID underscore the I for I in. Sorry, I think my keyboard is messed up, so it keeps like backspacing on me. So now we get the IDs. So the IDs will look like this. Sorry, let me adjust my keyboard for a second because it's messing things up. So, one second, guys. Okay. Sorry. So now you have the IDs like this. Okay. So now let me show you like the actual adding the documents, metadatas, and IDs to the database. So you're gonna do that by doing collections that add, and then you add your documents, your metadatas, and your IDs. So this adds it to the database. So once we've added it to the database, now we can query, right? Okay, so now we can query things. So let me show you an example. So like, let's say we can do results equals collections.query, and maybe I'll ask what is on saying about EV demand. So this is something I was actually once interested in because on said something about EV demand, and then Tesla crashed because of it. So I thought that was an interesting thing to look at. So you can do this, and then you can look at the result. So query text is a list of queries you want, and end results equals 2 means you have two results for each query text. This will give you the two most similar things. So like if I go results like this, I'll get the two most similar things. If you don't do anything, it'll do everything for you here. So that's a lot of things, but just a quick thing, you can add another thing. You can say like, I am Michael Jordan. I wish. I'm just kidding. So this is I love Michael Jordan. So you'll have two, and each will have the two most similar, meaning the smallest distance between them, results. So like if I go all the way up one of these days, so you see like I have the two most similar things to what is on saying about EV demand, and I am Michael Jordan are these ID 1 and ID 2, and then ID 12 and 15. Okay, but if you look at the metadatas for what is on saying about EV demand, you'll notice that the metadatas are actually symbol is Tesla, so Tesla earning call, and symbol is Tesla earning call. So that's actually not what we want. So later I'll show you how to filter that. And by the way, there's this include thing. By default, it included all these things, but you can choose to return only the embeddings, the metadatas, the documents, the distances, and that sort of thing. So let me just show you an example. So I can do like results equals query. It's amazing the autocomplete, how it. So I can say what is on saying about EV demand, and let's say I want to include metadatas, and let's just do end results as 3. So you see I get the metadatas. You always get the IDs. The metadatas you get 3 things now, and everything else is none, right? And I can also do like embeddings, right? And then I get the embeddings. Okay, so that's just an example, and you get these embeddings, but let's just keep it at metadatas. Okay, so so now look, this is actually not what we want because I'm asking what is on saying about EV demand. I'm not even reading the earning transcript yet. And by the way, another reason why you should split this giant document into parts is on talks about a lot of things. The EV demand is only part of it. So like you don't want the whole document, you just want one part of it. But that's beside the point. I want to show you guys like, okay, so there's maybe 2 ways to get on as the people talking about EV demand. So there's 2 types of filters you have. So here without the filters, you just find the 2 most similar documents in terms of embedding distance. But you can further refine this by having document filters and metadata filters. So like document filters, they have the syntax where document, and you filter on exact words in the document. So you basically have like the syntax is operator and your search term. So, and it's not the most sophisticated, like it's not like case, you can't really do case insensitive, for example, but here case sensitive, so case insensitive, sorry, but we want case insensitive anyway here. So like one way to say like we want on earnings is we want on to appear in the text. So we can say, what is on saying about EV demand? Same as last time, but here it contains on. So let's look at the results. And by the way, when I did include, sorry, let's add the includes thing. Let's do include equals metadatas, because it's a little confusing to read everything. So I'll do include equals metadatas, right? And then where document is on. So you see now, the metadatas, I am getting on, I'm getting on, and I'm getting on. So that is better, more correct. Okay, but maybe a more natural way to do this is like we can filter on the metadata itself, because one of the metadata columns is the symbol, right? So we have these metadata filters, and they use something called where. So the syntax is where your metadata field, and then operator, your search term. And you can also have like multiple things like ands and or. You can have metadata field, operator, your search term, like, and it'll have an or here, second search term and second field. And these are the types of operators we have. We have equal, not equal, greater than, less than. These are for numerical types. In and not in is for lists. I'll show you a few of these examples, but like with the on example, basically we would want something like results equals query.collection. What is on saying about EV demand? And then write where, and then equals, not Tesla, on. And then you get the results, and you see it's all on earnings, because you get like symbol on, and symbol on. So that's more on the right track. There's also, by the way, a shorthand version of this. You don't necessarily have to write metadata field colon operator and then what you're searching for. You can also just do if you want equals, you can just do a symbol and then on. So that's interesting. Oops, sorry. That's shorthand. Okay, so now let me show you like an and condition, and also so I'm going to show you like, okay, so I'm interested in symbol is on, quarter is Q1, and year is greater than or equal to 2023. So I'm also going to do like results equals collection.query. What is on saying about EV demand? Include metadatas. And now I'm going to want this filter. Wow, the AI is really good. It actually was able to realize that I want symbol is on, I want quarter is Q1, and year greater or equal to 2023. So the syntax is you have the like conjunction thing, like and or, and then a list, right? So all these have to be true. So greater or equal to 2023, and then we'll get the results. We got nothing, so I guess there isn't anything like this. So what did I do wrong here? Maybe I'll write this. Must have done something wrong. Anyways, oh, quarter is, remember our data frame? Our data frame was DF, right? So our quarter is like 1, 2, and something. Okay. So so if I do quarter is 1, does that work? Yes. So I get it. Okay. And then there's an example you can do like in and not in. That's very useful often. So I can do like results. Let's see if the AI will get it this time. Equals collection.query. What is on saying about the EV demand? And I'll do like end results equals 3. Include this, and then I'll do where and look, it's nah, I don't like that. I'll do symbol and then remember we do the condition. I'll do in. So the symbol, let's just say, is on or Tesla, just for the hell of it. But we'll make another one, symbol just being on, just for the hell of it. So that's the like conjunction condition. Oh, sorry. Maybe we could do something like this. We could do like a symbol. Let's do equals on, and then this is a useless condition because they contradict each other. But I'll do like I could also do symbol in on, and then I can do just to show you guys. This is still a and condition. So I can let's add a not in. So let's do like symbol not in. And I'll post this on GitHub, but not in Tesla, Rivian. So because this is an or, we're gonna get everything. This is an and. We're gonna get everything. Sorry. Okay. So what did I mess up on? The AI went too far. Equals on. Okay. Here. And then here. So now you see like it includes just the on thing, and it's right. But let's just make it like something that gives you no results just for the hell of it. So we'll do an and of a condition that never works. And sorry, I haven't made a real video in a long time, so I'm a little bit flustered. So I can do like instead of and, I'll do and Tesla. You can't have on and Tesla, so it's gonna give you 0 results, right? But then I'll show you like an or condition, right? So you can do or condition, and now it'll give me results because at least one of these is true. And here, of course, you can't be in on equals on and in Tesla. It's just not, you can't have both. You can also have nested conditions if like one conjunction is not enough. So let's see if the AI will automatically write a query for me like this. So I'll do results equals collection.query, and then I'll do include. The AI is not as good this time. Metadatas, and then I'll do where. Okay, so this is a conjunction example, and I guess it didn't finish it for me. So here I'm doing and. So what this is saying is you want symbol is on, and this is one and. But then within that you have one condition that symbol is on, and you have another condition which is basically an or of symbol is in Tesla. And symbol is not in Tesla or Rivian, or of those two. So we should we get nothing here because you can't have both of these. But let's show you how it works. I guess you do because the symbol is on. Here, symbol is in Tesla and not in Tesla Rivian. Oh, so this contains on. So you do have a lot of things here. Okay, so it's showing you that one. Okay, so enough with those examples. This is supposed to be just an intro. So like, there's some useful functions. Like in other databases, you can count the number of documents. You can basically do collection.count. You can see the first few items. You can do like collection.peak and the number of items. Okay, so I hope this gave you this gives you the first 3 items. Sorry, doesn't look like that. But if you scroll up very fast, you get the first 3 items. See, it has all the embeddings and the look at the embedding vector and the IDs of the first 3. Okay, so let me show you guys a more customized example. So remember, the first thing I talked about was persisting it to disk and not having it just in memory. Because we don't want to recompute the embeddings, and we want to maybe like extend our example in the future and extend our database. Or we want the database ready to go and just add to it when we have a new thing. So I'll show you how to like persist it for later usage. A small side note is because we are using Google Colab, basically your storage here is not persistent. So like if you like do a disconnect and delete runtime, you won't have your storage anymore. So I'll show you just how to copy it to like something like Google Drive so you can use it for next time. And then I'm going to show you how to use the two most important components of a RAG system or a vector database that can be customized with ChromaDB. That's the distance function and the embedding function. So first, let me show you the persisting part. So for the persisting part, we do something like, we first create the client again. So I'll do Chroma, 1 second. Let me just remind myself of something. I'll do like something like, maybe I'll do client equals ChromaDB.persistent client, and I'll call it my collection. Oh, sorry. The path is where we want to save the thing. So I'll put it location, right? So let me see if it created something yet. So it did create something yet. And it's like an empty thing, right? So I have the location here. Okay. So now I want to show you like you can choose your embedding function. So you can basically, it uses sentence transformers by default, but you can use embeddings from like OpenAI, Google, Cohere, Hugging Face, all those like famous competitors. But if you look at the link I had here, by default it's sentence transformers. So basically, if you go to like Quick Start here, it gives you pre-trained models. You see like there's some pre-trained models. We'll just use the first one here because it seems to have the best performance out of the listed models here. So I'll copy this and then copy the name. I'll try to copy the name. Okay, copy. So now what I do is I'm gonna have to basically import this from the sentence transformers. So let me do import torch. Import sentence from sentence transformers, import sentence transformers, and I said I want this transformer. I want the model name equals I didn't want the mini one, I want the bigger one, like this guy. Okay. So another thing is I imported torch because if you imagine you're using like a local model. You would want to use a GPU if you have a GPU. I happen to be using a CPU because I have like a dummy example with like 20 things. But you should always do this and use a GPU when possible. So you do like device equals device. So this gives you the GPU to use. Okay. So this will be our model. Maybe I'll call it embedding function. That's a better name for it. Oh, and sorry, this should be sent. Damn, the Google auto complete is wrong. So this should be sentence transformer.embedding function. So the AI is not perfect yet. So do embedding function. From sentence transformers import. Oh, sorry, I need from. ChromaDB.utils import embedding functions. So then I'll need embedding functions dot sentence transformer embedding function, and then I give the model name and the device, and hopefully this will work. Oops. So it's actually model name. Sorry guys, the auto AI complete messed me up a bit. So now I have the embedding function. Okay, so to create a collection with this embedding function, we pass it. And by the way, you're going to always need to pass this embedding function in the future once you define it once. So I'll call it my collection. Maybe I'll call it new collection. And then embedding function equals embedding function. So I'll do create collection, new collection, embedding function. Okay, so now I'll show you how to create the choose the distance metric. So by default, it's actually the inner product. But in my other examples, I showed you how to use cosine similarity or cosine distance. So let's do that. So you do you know what? I actually needed to add it here. So you know what? Let's actually put it here. So I'll do collection dot create collection, and then I'll do name equals new collection. You know what? I'll do get or create, because we can get the one we just created. New collection. Embedding function equals embedding function, and distance equals how do we add it? We add it like this. We do metadata. We do something like metadata equals sorry, this is covering it. This thing, whatever this thing means, and then cosine. So you put the parameter. If you want L2, you put L2 here. If you put inner product, you put inner product. Again, I'll put this in my GitHub. So this creates the collection. Get, what the hell? Oh. I'll do, sorry, collection equals client dot get or create collection. New collection. Okay. So now I'm going to add to the collection as we did previously. Remember the collections dot add thing with documents, metadatas, and IDs. What did I spell metadatas wrong? Oh, I spelled it metdatas. Okay. Okay. So I'll fix that spelling. Okay, great. So now this is where you add to the collection. Okay, and by the way, when you add to the collection, you'll see that in the location folder, you're gonna get like the database, the embeddings info, and let's let that finish, and you'll see. Check the stock market in the meantime. Ooh, not good. Rivian's not good. Anyways. So, okay. So now if I refresh this, you'll see this is where the embeddings are stored, kind of like here. Okay. So, so now we have a persistence location folder. So we can reuse this. But because we're using Collab, and if we like delete the notebook, we won't have access to it. So let's actually copy it to Google Drive. So you mount your drive, you do from google.collab import drive, drive.mount content.drive, and then let's copy it. We'll do copy negative recursive, if you know Linux, to content drive my drive. This copies it to my drive. Connect to Google Drive, allow, great. Great, so we connected it to Google Drive. We saved it in Google Drive, so by copying it, and great. So now let me show you guys, assuming we restart the notebook. So now it's in Google Drive. So actually let me show you guys, I guess I'll refresh. Oops, what happened? Drive, and I go to basically, what the hell happened? My drive. And you'll see I'll have a location folder, and it'll have this info. Okay, so let me, I guess I did it multiple times, so hope it still works. So now if I were to like delete or restart my runtime, I can still have access to it. So how would I have access to it? We'll load the database and show you how to use it. So like, let's say you come back tomorrow, right? So then you can just do import ChromaDB, client equals ChromaDB.persistent client, path equals location. It's actually not there yet, but then we do client.get collection. New collection is what we called it. So remember, it's in Google Drive, because when we restarted it, maybe you have to, if you have to delete it to not see it, maybe. Okay, so I guess you know what? Let me show you guys. Actually, let's just do the whole thing. So let's actually delete this runtime. Disconnect and delete runtime, right? So now, like, you're from scratch. You have no files here, right? So now we have to start over, right? So I do pip install ChromaDB. Oh, and I'm gonna need sentence transformers too. That's gonna be annoying because that takes a long time. Okay. But anyways, we'll let it give us an error in a second. So now it doesn't have that. So we need to let's first mount the Google Drive and then copy it from Google Drive to the non-Google Drive, just because the performance is bad on Google Drive. So we do cp-r location, content to location. So here it's basically copy to local file system from Google Drive. And we're gonna get an error because there's no package sentence transformers. But anyways, you have to do get collection, and you have to do. Let me make the entire example. Let me make it proper, okay? So the second thing we need to do is pip install sentence transformers. And then what we need is to copy the thing above. We need to do this thing, because we need to always give it that function. So I'll do it like this. Okay. So this installing sentence transformers takes some time. Let's look at our file system for a second. So I didn't mount anything yet, so I basically have nothing. Let's wait for this to finish. Sorry, I rambling a little too much. If you enjoyed the video, please like and subscribe. Let's wait for this to finish. Wow. Why is Rivian dying? Okay, so it takes forever. Okay, this is just showing you like if you were to start from scratch what you would do. So you have to do takes forever. Great. So now I'm mounting the drive, and then I'm copying from the Google Drive to the local storage on Google Colab. So that's what this will do. So you'll see both. I'll have the drive part in the file system. If I do refresh, oops. Why is this stuck? What the hell is this thing? This thing, it insists on hiding it. Anyways, the location is here. I'm sorry, something's wrong with my keyboard. It's like automatically clicking. Okay, so now that we have the location, we can load it. We write our embedding function. The first time it takes a little bit because it's downloading it. And then we remember we do we have the persistent client. We give it a path, and then we get collection, and it's called new collection. And then we have our embedding function equals emp. What the hell is this thing? I don't know how to get rid of this thing. It's weird. Okay, anyways, so we write our embedding function. I just wanted to make it proper, that's why I'm taking all the steps. M function, sorry, what did I call it? I called it M function, and then we have our metadata. H space was the cosine similarity we wanted. So this gives us the collection. One second. Weird. Okay, so now let's see if we can just search things and get it. So let me just do like a query, like what is on saying about EVs. Sorry for the mess at the end. Anyways, you get your answer here. You get the distances, metadata. So you see how we reloaded it from disk. Anyways, sorry about the end. I hope you guys enjoyed this video. Please like and subscribe if you're new. And if you're old, please like and share. Thank you so much. Have a great day.